Welcome to another training episode. So in this video, we are going to look at dynamic routing. So here we have a simple network, HQ and a branch router. So each has one department, the sales department and marketing department. So our objective here is to ensure that sales and marketing staff have to communicate. So basic configuration has been done on all of these devices, that's the routers and then the computers, that is IP address allocations. So now let's test communication from PC1 to its gateway, that's the IP address on the 1/0 on the HQ router, by using the ping command. So from PC1 we ping the IP address of its gateway, that's 192.168.1.1. So that is replying fine. You can see the reply packets are coming through. Okay, so let's also ping the IP address of serial 2/0 on HQ router. So if you ping that, it's going to be 10.0.0.1. So reply also is coming to PC1 from that interface. So let's try to ping from PC1 again towards the branch router as the first IP address that's on serial 2/1. So that ping is going to fail. Ping 10.0.0.2. So here you can see we are receiving ICMP sequence 1 request timeout. So simply because routing is not in place, and we said that routing can be done in two forms. One is statically, or we done it dynamically. So remember, in our last video we dealt with routing using static route. So here we're going to look at dynamic routing. So in dynamic routing you can have different routing protocols. So here we're going to do dynamic routing with a routing protocol called RIP. It is one of the simplest to configure and the routing protocol that is used for small networks. So here, before we proceed, let's go to HQ1 and see that HQ1 only knows about the networks that are local to it. That is this 192.168.1.0 and then the 10.0.0 network. But the HQ router will have no idea about reaching 192.168.2.0/24. Now let's go to HQ router and see that it only knows about the local networks. So in HQ router, we can issue the command show IP route and see that the HQ router knows only about 10.0.0/30, and that is the one link going to BR1. It's also have an interface IP configured. That's why you can see here L means local to it, directly connected to serial 2/0. That's its IP address from that subnet. So the same router also knows about 192.168.1.0. That's the LAN network connected to this sales department, and also an IP address is configured on the 1/0 of the router. So, but the router also knows about the network that is on BR1 LAN, that is the marketing department. So that is why the communication coming from PC1 to PC2 will fail, and that we have seen in the ping command that we just sent. So that is when we try to ping 10.0.0.2, that is the next router, it was not working. So if we even try to ping the IP address on PC2 on the marketing departments in BR1, that will also fail as well. So let's just try that. Ping 192.168.2.10. So here you can see it says destination host unreachable, because that packet was forwarded to the HQ router, which is the gateway of PC1, but HQ router, which is supposed to forward the packet, has no idea about reaching the network 192.168.2.0. So now let's try to make sure that this HQ router knows how to get to the marketing department in BR1. Likewise, BR1 should also knows how to get to PC1 on the sales department in the HQ. Okay, before we proceed, let's go to BR1 and see also that BR1 also knows about only two networks that are the local LANs. So IP route, you can see BR1 only knows about 10.0.0/30 and 192.168.2.0/24. So routing here, we can do it using RIP, which is very, very simple to configure, we can do it in just 2 commands. Okay, so we go to global configuration mode from the HQ router, and we say router RIP version 2, because RIP comes in 2 versions. The first one was version 1, and it is now upgraded to version 2. And then we advertise the network, or we announce the network, and we advertise the network, 2 networks here. That's the network connecting to BR1, and then the network that is the LAN connected on the LAN network. So we advertise 2 networks here. That is the network on the one link as well as the network on the LAN. So network 10.0.0.0. So note that in RIP you only advertise the classful network. So here you can see the 10 network is a class A. So the classful network is a class 8. And then we advertise the second network, which is the 192.168.1.0. So here also we advertise the classful network, which is a class C, a class 24. And we enter. So we can say no auto summarizations, no auto summary, and that's it for that router. So you can see we can save that. We only enable the routing protocol, that's router RIP, as the RIP engine will be turned on, and we see in here is version 2, and then we advertise the network. So if we have another LAN, we just have to advertise that. But here we only need to advertise 2. So let's go to the second router, that is BR1. So since we are done with HQ router, we go to BR1, also go to global configuration modes, and enable the routing engine, and we see it is version 2, and we advertise the network 10.0.0.0, and we advertise the LAN interface 192.168.2.0. okay, and we can also say no auto summary. Then we can save our configurations. So you can see it's very simple to configure routing protocol using RIP. So now let's see the networks that are LAN using RIP. So remember that when we check the routing table initially by issuing the command show IP route, we discovered only 2 networks that we are LAN. That's the ZC route 10.0.0 and then the 192.168.2.0. They are all directly connected. So now we expect to see a new route that is introduced in the routing table by using the routing code R. That means RIP. So if I issue the command show IP route, you can see that we have a new route inserted into the routing table. And here you can see we the routing table says 192.168.1.0/24 is a RIP route. It's LAN via RIP. And now to get to this network, we go to next hop of 10.0.0.1. That is the IP address on serial 2/0 of HQ router. And the outbound interface, that is the interface we use to get to that network from BR1, is serial 2/1, which is this interface here. And now you can see something very important here. It's saying the administrative distance is 120. So this tells us that this is a RIP route. Okay, and now the metric is 1. So for RIP, it uses a metric of hop count. So that means the number of route, that is the number of router that is going to go through to get to that network. 1 hop count. So that means if it leaves BR1, it's going to hit HQ, that's 1 route, and bam, gets to the network. So RIP uses hop counts. So that's it for BR1. So if you go to HQ now, also we should see that HQ router is able to LAN the remote network via RIP, because initially here also you can see it's only 2 routes that we have. So likewise here we should expect to see a new route that's introduced using RIP. So here you can see 192.168.2.0, which is the marketing department in BR1, is LAN via RIP, administration distance of 120, and the metric also is 1. The outbound interface is serial 2/0 from this router. So now communications that was failing from the sales department to marketing department should succeed. So let's go back and test it again. So we test from PC1, try to hit PC2 on that IP address. So we record the ping command, and now we should expect to see a reply. So the first 2 packets were lost, and now the following packets came successfully. Okay, so now we can also trace. If we trace to that PC, we should be able to see that packet is going through the gateway router and all the way to that PC. Okay, so the first hop was the gateway 192.168.1.1 of PC1, and it goes to the IP address 10.0.0.2, that's the serial 2/1 of BR1, and it finally hits the PC2 marketing department. So that is for RIP, and now check us on our subsequent videos for more advanced RIP configurations as well as other dynamic routing with advanced routing protocols. So if you want to see more videos like this, please subscribe to our channels and then hit the bell icon to see notification as soon as new videos are released.